Today's main discussion is going to be about limits. Though before we continue with limits, the last time we were discussing, we're looking at finding the domain of a function, right? So today we're going to begin with finding the domain of a composite function. So we have a composite function that is fg, and fg is a function where f of x is equal to x squared plus 2, and g of x is equal to the square root of 3 minus x. So remember we said that a function has to have a rule and a domain. This is how we describe anything called a function. It has to have a rule and has to have a domain, right? So now we have this composite function and we want to find the rule, which is going to be f of g of x, which is going to be equal to f of the g of x, which is the square root of 3 minus x, which is going to be equal to the is going to be equal to this, which is the square root of 3 minus x, this whole thing, because you're substituting for the x, this whole thing squared plus a 2, and you're going to have this being 3 minus x plus 2. This is a very interesting thing. So this whole composite function becomes the rule of this function becomes that is 3 plus 2, which is a 5 minus x. But now we don't have the domain, right? We don't have the domain. So how are we going to find the domain of this composite function? Now, to find the domain, we have to find the domain of this function, and we have to find the intersection of the domain of this function and this other function. How are you going to do that? Remember our function g of x is equal to the square root of 3 minus it is 3 minus x. So we want this 3 minus x to be greater than or equal to a 0. We don't want that to become a complex number, right? So to do that, we are going to get the 3 greater than or equal to x. This is going to be the domain for the g of x, right? So now this domain is running from 3, right? So these are numbers that are less than 3. So it's running from negative infinity to 3 inclusive. 3 is the maximum. So this is the domain. And the function f is as you can see, it is a polynomial, right? And we know that the polynomials, that is x squared plus 2. These polynomials are defined on the entire real line. That means that its domain is from negative infinity up to positive infinity. So now the intersection, that is where this negative infinity, because we have negative infinity up to positive infinity, where this domain of this function intersects with the domain of this other function, that is from negative infinity up to 3, this here is going to become the domain of our composite function. So in the end, we have a composite function which is f of g, which is defined such that we have 5 minus x being our rule, and the domain being from negative, and the domain of this function being from negative infinity up to 3. So this is going to be our domain of the composite function. That is where we stopped last time.